All right, so this video isn't going to be much more of a stretch from what you saw on 3-1. We're still doing linear systems of equations, except we're in 3 variables now, which means we're looking at 3x4 matrices. And I don't know if we'll get into matrices or not, probably not, but we're looking at 3x4 systems, we'll call them that then. Okay, so here's our EQs. So how do we use, and these look familiar, how do we use substitution and elimination to solve 3x4 linear systems? And EQ3, of course, how can we formulate linear systems from real situations? So here's our first example. And I'm really just going to do these 2 examples to answer EQs 1 and 2. One example to show how to use substitution, which is so brutal on 3x4s. And one example on how to use elimination on 3x4s, which is a lot, less horrible. Okay, so for substitution, it's pretty much the same idea, and also for elimination. They're both pretty much the same idea as what it was for the 2x3s. You're going to want to get a variable by itself and then just start plugging in to try and solve for the others, right? Excuse me. So we're going to start here, okay? And this is the tricky part to substitution is you start with one place and then you can't use that one again in the next step. You'll see what I mean here in a second. So I'm starting with this top equation. I'm going to go ahead and get z by itself so that I know what z is and can substitute accordingly, right? So z is equal to, if I just do minus 7y minus 2x, z is equal to negative 2x minus 7y minus 53, okay? So what I'm going to do now is take z and plug it into this other equation and try to isolate another variable much in the same way. So I'm going to plug into another equation for it, and then I am going to substitute again, right? And I'm going to try and color code this to keep it as not horrible as possible. So right here, we've got negative 2x plus 3y plus z. And z is negative 2x minus 7y minus 53. All of that is equal to negative 13. And you can see now, instead of dealing with 3 variables, we're only dealing with 2 variables. Okay, so it's already gotten a bit simpler, right? So we're that much closer. Okay, so I don't need these parentheses here. There's not anything being distributed into them, so I'm going to go ahead and drop them, and I'm just going to combine like terms where they are, and then I'm going to solve for another variable, and I'm going to see which one's going to be easier. So negative 2x, so that's going to give me negative 4x, positive 3y, negative 7y, that's going to give me minus 4y, and then we've got the minus 53 there, the only constant on the left side of the equation, bring down the negative 13. So I'm underlining to show that everything's been accounted for. This is important because it helps you stay organized. Okay. All right. So I think I'm going to go ahead and solve for x just because why not? Or you know what? Let's solve for y, because if we started with z, I'm going to work backwards alphabetically. I'm just weird that way. So anyway, so I'm going to add 53 and 4x to both sides. So plus 53 plus 4x, right? That's going to leave me with negative 4y is equal to, so negative 13 plus 53, that would combine into positive 40 and plus 4x. I can divide everything by negative 4. Does everyone see that? So I can divide everything by negative 4, so y is going to be equal to negative 10 minus x. So now I know what y is, right? So now what I'm going to do is I'm going to take y and plug back into, sorry, I've got music playing loud in my ear and it was like really annoying. I'm going to take y now and plug back into z here, okay? I'm going to take y here and plug back into what I got for z originally, okay? And let me think, would that be the way to go? Actually, no, I'm not. I'm going to plug into, so I'm going to take y and plug into y here, And also take what I know x is, or sorry, not x, z, and plug in for z here. Okay, then you're going to see I only am going to be dealing in one variable. You'll see what I'm talking about here in a second. So I've got 6x plus 3 times y. Well, this is y. Negative 10 or negative 10 minus x. Okay. Then I've got plus z. Well, z is this right here. So plus negative 2x. And then minus 7 times y. Well, we know y is negative 10 minus x. And minus 53. And I ran out of room. Let me give myself some room here. Might as well get rid of that. I'll leave that part though so I can see what y is equal to. Okay, so z is equal to negative 2x minus 7y. So I substituted for y and I substituted for z. Okay. Anyway, so 7y and then minus 53. And all of that is equal to, and I'm using this third guy down here, negative 45. And you can see this is getting really crazy and it's really easy to mess this up. Okay, so I'm going to just slowly start breaking this down. So 6x, distribute the 3 in here, so minus 30 minus 3x. And then I don't need these outer parentheses, so I can go ahead and just say minus 2x, distribute, that's going to be plus 70, distribute again, that's going to be plus 7x, and then minus 53 equals negative 45. So again, keeping organized, I'm going to start combining like terms. So 6 minus 3 minus 2, so that's minus 5. Okay, so 6 minus 5x, that's going to leave me with just 1x plus the 7x, so I have 8x total. Okay, negative 30 plus 70, well, that's 40. 40 minus 53 is negative 13 equals negative 45. Okay, so I've accounted for everything. Okay, so I have 8x is equal to, well, I'm going to add 13 to both sides. So that would put me at negative 35, negative 32. Okay, then I'm going to divide by 8 on both sides. I get x equals negative 4. So finally I've got it. Okay, and you can see substitution, if you don't have to, substitution is not the way to go, man. Not the way to go. Anyway, so x is equal to negative 4. So what I can go ahead and do is plug in what x is equal to right over here to figure out what y is. Then when I know what y is, I can plug that in over here to figure out what z is. Okay, but I'm getting ahead of myself. So let's do that. So x is negative 4. So y is equal to negative 10 minus negative 4, which of course is negative 10 plus 4, which is negative 6. So y equals negative 6. Okay, so now that I know that, I'm going to take x and y and plug both of these guys in here. Okay, so z is equal to negative 2x minus 7y minus 53. Okay, so this is going to give me positive 8 plus 42 minus 53. 8 plus 42 is 50 minus 53, so z equals negative 3. So my solution set is x, y, z. This would be my solution set. And then, of course, just like anything else, I can, I can check my work. So I'm going to take this equation. It looks slightly less ugly than the others. So 6 times x plus 3 times y plus z, lost my spot, z is negative 3, I'm an idiot, equals negative 45. So this should be true, assuming I didn't goof, which is always very possible if you're not careful. So negative 24 minus 18 minus 3 That's going to give me negative 24 minus 21, which of course does combine to give you negative 45. And thank goodness, because now I don't have to record the whole video over again. Okay, so now let's get into the less gnarly. So elimination is going to work much the same as it did with the 2x3 systems, right? So we're going to look, and if you look here and here, we see that we can go ahead and combine these two, and we'll be able to eliminate, what we call it, z. Okay, so let's do that. So 2x plus y minus z equals 4. And then we have x plus 2y plus z equals 11. Okay, so we can go ahead and combine down because we're going to get an elimination. Right, so this would be 15. This here would be 0z, which we don't really care about. 3y and 3x. Okay, and that's positive 3y and positive 3x. So now I've got 3x plus 3y, and you're going to see this is going to work out to be, we're going to solve a little miniature system to get a few variables. Then we're going to substitute back in for some stuff at the end. Okay, so we found those two. So now we need to use a combination of two different ones, right? And just looking, it looks like it'd be easy to combine these two and get rid of x, plus 2x minus 2x. So let's go ahead and do that. 2x plus y minus z equals 4. 2x plus y minus z equals 4. Negative 2x plus y plus 2z is equal to 6. Okay? And again, look how organized I'm being. Okay, I'm color coding, I'm, staying neat, right? Y'all that are really messy when you do math are going to have the hardest time with this because, well, you're not staying organized. Okay, so 4 and 6 combines to 10, negative 1, positive 2 combines to positive 1z, then we have 2y, and then we get our elimination of x. Okay, and I'm an idiot, but I'll show you why I'm an idiot. So the reason that I'm an idiot is that I didn't eliminate the same variable as I did here, right? You have to do that. So if I write this underneath, right? So I've got 2y. Well, this guy doesn't have a z, right? But this guy does. So this does me no good. So everything I did was just moot. Just moot. Just a waste of time. I'm gonna retain my pride a little bit and say that I was showing you how to avoid a mistake. Anyway, so we eliminated z from here. Yes? So we want to eliminate z again. Okay, so we're gonna use these two because why not? Right? It's a combination of two different ones than we used the first time. Okay, so we're gonna eliminate z also. And to do that, so I've got 2x plus y minus z equals 4. And negative 2x plus y plus 2z equals 6. Let me make sure I copied that right. Okay. To do that, I'm going to multiply this entire top equation by just positive 2 so that I get a negative 2z right here to combine with this positive 2z. Okay, and now you see the reason that I put a line through my z's because my 2's look a lot like z's. Anyway, so when I multiply by 2, I get 4x plus 2y minus 2z is equal to 8. So 8, negative 2, positive 4. So now I'm going to combine. Don't need this anymore. Combine straight down. This gives me 14 equals 0z, which is what I wanted. I eliminated z from this guy over here on the top right also. 3y and negative 2x. No, not negative 2x. What's the matter with me? That's positive. Positive 2x. Okay. So now what I've got is a similar looking system involving x and y. So this is a little baby one. So I'm going to use elimination again here with this guy. Okay. So I'm going to multiply this guy by negative 1 just because I can. Okay, and that's going to make this a negative 3 so that it will eliminate with this positive 3. Okay, and I could have done it another way if I wanted to. So, and I'm not going to combine yet. So I'm going to have negative 2x minus 3y is equal to positive 14. Okay. Now I can get rid of that and combine. So 15 and 14, that is 29. This combines to 0y, and this combines to x, just 1x. And we have x equals 29. And I hope I didn't mess that up because that seems goofy. Ah, that is goofy. So once again, children, stay organized. This 14 is positive. For some reason, I wrote that the 14 was negative right there. I like how it drew a circle for me for no reason. So let me just back up. Back up, back up, back up, back up. Okay, so that 14, right, this is a positive 14, and I copied it down wrong. Okay, shame on me. So that's a positive 14. So I'm still going to multiply. I'm still going to multiply by negative 1. I think I was getting ahead of myself in my brain and wanted to go ahead and multiply by negative 1 too soon. So negative 2x minus 3y equals, now it's negative 14. Okay, so this is gone. So combine down, so that leaves me with 1 minus 3y plus 3y, that combines to 0y, and 3x minus 2x, that leaves me with just x. So I'm left with x equals 1. That makes sense. Okay, so now that I have x, right, all I'm going to do is substitute back in to one of these little baby equations. I know what x is, so 3x plus 3y equals 15. I'm going to solve for y. Then when I know what y is, I'm going to plug back into here and solve for my missing z. Okay, so 3 times 1 is 3, plus 3y equals 15, 3y equals 12, y equals 4, and y is equal 4. So now I have x and y, so I'm just going to choose this guy on top. Seems like the simplest one. 2 times x plus y minus unknown z equals 4, right? So that's just 2 plus 4 is 6 minus z equals 4. Subtract 6 from both sides. Negative z equals negative 2. Z, therefore, is positive 2. So my solution set is 1 by 4 by 2. Okay, and we can check our work, right? So I'm going to use this equation to check my work just because why not? So x plus 2 times y plus z is equal to 11. Let's see if that's true or false. Okay, so 1 plus 2 times 4, which is 8, plus 2 is 11. So something is wrong. I'm not sure where I went wrong or if I copied the problem down wrong or something, but I'm pretty sure. Oh, I'm an idiot. I forgot to add the 1. So this should be 9 plus 2. Okay, and that would be 11. Okay, so you can see it's really easy to make a mistake. I've just done this enough times to know if I probably did or not. So it's going to be a little bit of a mess at first. Okay, so bear with me. The assignment's probably going to take a while. I'm going to go through the lesson quickly so that you have enough time to work on it for yourself. Anywho, so here's a real world quote unquote example, right? So a snack company plans to sell a mixture of peanut butter, grape jelly, and granola, can't talk, as a sandwich spread. The table gives information about each ingredient. Sorry, I had to drink some coffee. Okay, an 18-ounce jar of the sandwich spread will have a total of 2,273 calories and 150 grams of fat. Write and solve a system of equation to find the number of ounces of peanut butter, grape jelly, and granola in each jar, right? And there's just a random line underlined right there. I don't know why that's there. Okay, I think I've got it figured out. So the way that this is going to work is, okay, so the calories is going to come from this column here. Okay, so that would be 168 calories from peanut butter plus 71 from jelly plus 132 from granola should give me 150 grams of fat, right? So then you look at, oops, that's not what it should give me. We're looking at the calories. This is calories. This is calories. So that should give me 2273. Okay, then we're looking at the fat. So we're looking at 14 of peanut butter plus 0 of jelly plus 12 of, what do you call it? Granola. And I call that a bunch of baloney. But that's the grams of fat, 150. And then we're talking about just the weight or the mass of the jar, which is an 18-ounce jar. So that's just the raw amounts. So peanut butter plus the jelly plus the granola gives us the 18 ounces. Okay. So from that, we have a system. I'm not going to actually solve this one. I'm going to leave this to you as extra credit. So by all means, get after it. See if you can solve it. Any questions, comments, concerns, obviously shoot me an email or let me know in class. Goodbye.